first question, we want to understand why using indices. Also, I need to explain the indices in our database context. The meaning is special. Indices. All right. Why use indices? First, let me describe the background. So for this topic, so although it's a theoretical topic, but this background knowledge is useful for us when we need to solve some real-world problems. So you need to have, some good background knowledge when you design your databases or when you write your query statements. So at the background, how does the DBMS work at the background? So that is important. All right, so here, the goal for this technology, so it's a special type of technology. So the goal for this indexing technology in database, speed up the retrieval of records in response to certain search conditions. So think about it. So that's important, right? So first, this technology is used at the data retrieval. Select statement. So when we write our query statement, select statement. And we want to have very fast response time. So how to do some special things in DBMS behind the scene. You cannot see it. Okay. You cannot see it. But you need to set up. You need to set it up in the DBMS. In order to support this technology in response to certain search conditions. So that's the goal. Okay? Speed up. All right. How to make the data retrieval as fast as possible. All right. So the main idea for this technology, the structure of the data is important for the performance of data retrieval. So we need to take advantage of the special structure of the data. So this sentence is very abstract. So it's hard to see the specifics, the details you need for the implementation. All right? Pretty abstract. But here, so what's the structure of this? So the structure of the data. Later you will see. Here I can give you an example. If the data is ordered, that property, that's the special structure property. If the data is ordered, that structure is very useful in speeding up the data retrieval. It's ordered. So here you get an idea. For example, so that ordered data structure, for example, ordered data structure, ordered data, because this structure supports the binary search, right? when the data is ordered, then you can apply binary search, right? And we know the binary search, we can get a very fast performance. Yeah. How fast? Yeah. If you learn the algorithm, okay? If you learn the algorithm, so we have the performance description for the binary search if we use the asymptotic notation. Yeah. So when we describe performance, usually we use asymptotic notation. Yeah. So here, if we use the big theta as asymptotic notation, big theta of log base 2 of n. Okay, log base 2 of n. So here, n, the data size. Here, the meaning of n is the data size. Okay, data size here means the number of elements. Number of elements in the array. All right. But you may ask, what array, right? Yeah. So here, because here you may not have a understanding on that array, because our basic data, when we apply our select statement, usually we apply it on the table, right? Yeah. On table there are many rows. The data, the format of the data is like this. So we have a table. And in this table there are many rows in this table. Okay? Yeah. Then here we are talking about one particular column. Because for this table you have many columns, right? Yeah. But here, when we talk about this indexing technology, yeah, so we are looking at one particular column, yeah, one of the columns in this table. Yeah. All right. And this field, yeah, we look at this field. If it has a property, total order property. So this field, in order to sort the data, the minimum requirement for this field to support sorting, data sorting, or total order, right? It must have some total order. And most of the time, we have it. Okay, we cannot say 100%. Any field must have total order. We cannot say that yet. But that percentage is extremely high. Okay, 99.9 something. Yeah. So most of the time we have the total order. Yeah. So currently all the databases we have seen, yeah, has this problem. You know, the data have this property. All right, so usually we do not worry about this property, okay? If has this property, then those rows, yeah, so the rows can be sorted. Can be sorted with respect to width. This field. How about that? So that's the meaning order the data, right? Otherwise, you may ask me, You may ask me, what do you mean ordered data? Right? So now I give you the detailed understanding. Yeah. What's the meaning of ordered data? Yeah. So if you sort all these rows based on one of the fields in your targeting table, then you get an ordered data. Then you can apply binary search. So the data is ordered with respect to one particular field. When you do the data search, you can apply binary search. Here, I assume you know how to do the binary search. Okay? Yeah, everyone knows how to apply the binary search on an ordered array. Yeah. Yeah. So with this understanding in your background, now we can understand this indexing technology. Okay? All right. Yeah. But the original structure of the data should not be changed. Yeah. So yeah, because you apply search on this table, right? Search operation on this table. Yeah. This table is your original data. This is original data. Yeah. So you store your original data in the database, and you do not want to change your original data. Okay. The reason is simple, because the original data, you should not change its structure. No. No. Because we don't want to make our business data change, for our algorithm consideration. No. So this speed up thing, that's the algorithm. Yeah. The background algorithm. Yeah. Yeah. The users, most of the time, they do not need to know these special algorithms. The users, they do not need to know that. Okay? They just enjoy the search result, very fast search result. Yeah. But for us, the background knowledge is useful, especially when you write your query statements and when you design your databases. This background knowledge is very useful. Yeah. All right. Yeah. So here, the original structure. Yeah. We do not want to. Yeah. So the bottom line is, we do not want to change our business data for any reason. Okay. Even if for the algorithms to speed up the data search, we don't want to change our original data. Okay? Yeah. Yeah. So we will use another way. Okay? Yeah. So the idea is also very simple. Yeah. Let me derive the data. Yeah. And here we can assume the original data, most of the time, it does not support good performance, fast performance. Yeah. Original data, yeah. Yeah. Because it's not ordered, right? Yeah. Most likely the original data is not ordered based on any particular column. Yeah. Although in some rare cases, yeah, it could be ordered. Yeah. But even that, we cannot rely on that, right? We cannot rely on any ordering information in the original data. So we assume, none of the original tables is ordered based on any particular column. Yeah. All right. So the idea, all right. Yeah. In order to support this indexing technology, we do not touch the original data, but we can add auxiliary data to help us speed up the data search. So this is the idea. Create auxiliary access structures. We call it indexes. Yeah, so I will, next slide, I will describe the indexes. So, yeah. Based on indexing field. What's the indexing field? Yeah, so here, this is one of the indexing field. We can have several indexing fields, right? So one of the indexing fields in this diagram. Yeah. All right, yeah, so here, you get an idea. Yeah. Yeah. All right, next, let's focus on the auxiliary access structures, this indexes. So what are these indexes? All right. Multiple indexes, right? Yeah. So this last line, multiple indexes, different fields for this. Yeah. So this line, last line, tells us for one table here. Yeah, so here we're talking about one table, yeah, one of the tables in our database. We may create multiple indexes because we may have multiple fields. So, yeah, based on our business needs, we can create multiple indexes, yeah, when necessary. Okay. Yeah. All right. Now, let me explain the index basics. All right. The auxiliary access structures, data access, how to access data. We need some special structures to access data. Yeah. So what's the auxiliary access structures? Yeah. Yeah. So if you connect to the binary search in the previous slide, so you will get a picture of the auxiliary access structure. So we call it secondary access paths, not the primary. The primary access paths, we access our original tables directly. That's the primary access. Yeah. So let me write here. Yeah. Although it's obvious, right? So what's the primary access paths? Yeah. All right, so here, for the primary access paths, so that is direct access to the original tables. Okay. Yeah. 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 The secondary access paths. Secondary, we need to create it. If we do nothing, they are not available. Okay. Secondary access. If you do not create indexes, they are not available. Okay, the secondary access paths are not available. Okay, you can only use the primary access paths. Yeah. By default. So you may ask, by default, not available. Yeah. Right? Yeah. So then, but when we have large amount of data, so then we have option, we can create second secondary access paths to speed up our search operations. For relatively small amount of data, then we do not need to use secondary accesses. Relatively small. The table is not too large, then this technology, this indexing technology does not help. Okay, does not help. We know the binary search helps us speed up the search operation when the data size is relatively large. Okay, all right. Yeah. What's the secondary access path? Additional files on disk, hard disk. So here we're talking about the hard disk, hard drive. Yeah. You need to create auxiliary files. So here the files. Yeah. I mentioned before, here the files correspond to tables. Okay? Yeah. We need to create some new tables, auxiliary files, tables, yeah. Yeah. And store additional information. Yeah. So the information we add, yeah. So we add it to our primary data, secondary data. Okay, so that's the secondary data. Yeah, yeah, will be very useful in order to speed up the data search. All right, using extra storage space in exchange for better performance. Yeah. So the auxiliary data. So you have to use more storage space than the amount of space for your business data. Yeah. So extra data. You need to create extra supporting data to help you speed up the search operations. Yeah. How to, yeah, so let's continue. How to use these auxiliary tables to help us speed up the search operations. We sort the auxiliary files. How about that? We sort auxiliary tables. Yeah, so the files means tables, right? Yeah, files means tables. Sorting can be used in those additional files or tables. Okay? This time, we can apply sorting operations on the auxiliary files. We do not apply sorting operations on original files, original tables, because we don't want to change our original business data. If you apply sorting on the original, you change the structure of your original business data. So we don't want to do that. Yeah. But we can do it on the auxiliary data because we create the new data, right? Yeah. We create the new data. Yeah. So we have freedom to do extra operations on the newly created data. Okay? Yeah. So that's the idea. Okay? So that's the idea. Okay? All right. Yeah. It does not affect the physical placement of records in the primary data file on disk. Yeah. So we do not touch. Yeah. So we maintain our original business data. Okay? Yeah. No change on our business data. Okay? Yeah. 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 Yeah, but yeah, the supporting part, yeah, we attach the extra, additional supporting data, auxiliary, additional files, supporting, Yeah. So we can do the sorting. We can do the sorting, and we can apply binary search on the auxiliary tables. Yeah. So that's the main idea. Okay, so simple. Yeah, so simple. Yeah. All right. Then indexing fields. So in the previous slide, I drew the diagram. I show you the indexing field, right? One particular indexing field. So indexing fields, basically any field, basically any field of the file. I put a parenthesis, the minimum requirement, total order. Okay, any field with a total order, because we can do sorting. Okay, yeah, but any field with a total order, that's one of the cases. But there is another case. Yeah, so another case. Even if there is no total order, yeah, total order plus, because if there is no total order, we still have a chance to do the indexing technology. Yeah. Yeah, so here, because it's hard to say, here I say the hashing. I put the parenthesis. Okay. Yeah. If we can do hashing on the data, then we can make queries. Yeah. So here, this case. So you can imagine there are two cases. The first case, 90 something percent. Okay, 90 something percent. Yeah. This, small percentage. Hashing case, small percentage. Small percentage. Yeah. Largest part is our data has some total order, so we can do the sorting. Yeah. But there is a small percentage. The data may not have the total order. We can still do indexing, but we apply the hashing technique. Okay? Yeah. So I will explain more later. Okay? Later. These two methods we can use for indexing. So that's why basically any field of the file can be used to create indices. Although it's not 100%, very close to 100%. Yeah. So this sentence tells us, so very, very close to 100%, but not exactly. You cannot require 100%. Okay. Yeah. All right. So very close to 100%. Okay. But not equal to. Okay. So you cannot say, but not equal to 100%. Slightly less than 100%. Not necessary those fields with total order. Yeah. So here, yeah. Although most of the time, yeah, we can assume total order is available. Yeah. But there is a small percentage. In case the total order not available, so the hashing can be used. Plus the plus part, okay, hashing. Okay. All right, so I will explain later. Yeah, some do not use sorting. Do not use sorting, hashing. Okay. Hashing. I hope you have the hashing background from algorithms. So that's why. So what's the hashing? Right? So people may ask for you, what's the meaning of hashing? So, hashing technique comes from our algorithm class. Okay, 3130. algorithm. Yeah. Yeah. But for those students, yeah, because for this class, the algorithm class is the prerequisite for this class. So now you know the reason. Yeah. So because we need to use some of the algorithms background from that 3130 class. Yeah. But some students, I noticed, some students take these two classes concurrently. Yeah, that's fine. That's fine. Yeah. Yeah, but I will explain. Yeah. So at some time when I talk about the hashing, I will explain the basic idea. Okay. So let you pick up. Because some students, although they took algorithm class before, but they forget the details of hashing. Right? They may forget the details of the hashing. Yeah. So I will, summarize some main properties of hashing technique. Yeah. So very easy, not long. Just a few special properties, so we can use, to understand this hashing technique. Yeah. All right. B.2, data structures for indexing. So now we need to, understand more and more details, for the indexing files. So what's the detailed structures for an indexing file? All right, data structures for indexing. First, order the files. Okay, so the biggest part, although not 100%, so 90-something percent of the time, our indexing files are based on ordered files. So let's look at this case first. Require total order. So then we can apply sort, because this is the requirement for sorting. And the sorting, because after sorting, we can apply the binary search. Okay? Yeah. So this is the binary search based indexing technique. Binary search based indexing technique. Yeah. And there is another one, hashing based indexing technique. So basically there are two techniques. Yeah. So the first one is the binary search based indexing technique. Okay, yeah. First one. The second one, the hashing based indexing technique. Yeah. These two. All right? Yeah. These two. Okay. Yeah. Yeah. The first one, use binary search. Most prevalent types of indices. 90-something percent. The specific percentage number is not important. You just know. Most of the time, this technique is used. Tree data structures. Even for the binary search. So even for the binary search, the tree data structures. So this is for the improvement. All right. So why this tree data structure? Because think about when we apply binary search, our data format is an array, right? When we have a ordered array, suppose ascending order. The data is in ascending order. Then we apply the binary search on this ordered array. And here you can see, in this way, you need to arrange your data in one line. Okay, so that your data is in one line. Okay, if your data is arranged in one line, when you have a large amount of data, so that line is very long. Even you apply binary search, you need to do comparison many times, right? Think about it. You have millions of records, millions or billions of records, millions or billions of records. So think about it. For example, okay? So we look at when the data amount is huge, millions or even billions. Number of records, records are the rows, right? Rows or records. When you apply binary search, you need to do, relatively large number of comparisons, right? Billions of large number of comparisons. Okay. In that situation, how to reduce the number of comparisons? So we changed our storage way. Because we have freedom to choose how to create auxiliary storage files, right? We have freedom to choose. So the freedom we use, we store our data on the tree structure. So not a line structure. So this is the line structure, okay? So one line here. So this is the line structure. Line structure. Line structure, it's different from the tree structure. Because for the line structure, you store data in one level, right? That line corresponds to one level. The tree structure, you have multi-level storage. The tree, so look at the shape of, this is the tree, okay? In this tree, you have multi-levels, starting from the multi-level structure, okay? So it's a multi-level structure. With multi-level structure, you can store, when your data amount is huge, then we can use a tree structure to organize a huge amount of data so that when we apply the binary search, we can greatly reduce the number of comparisons when we use the tree storage structure. That's the idea. So here, let me give you the, high-level description. Here, I haven't given you the detail of the tree. So what's the detailed structure of that tree, right? So later I will mention a little bit, but so for this class, I do not plan to give you too much details, okay? Too much details about the tree structure. I mainly talk about the high level idea of this technology, indexing technology. All right, but here, so there is a tree structure we can use when our data amount is huge. Usually, only when the data amount is very large, then, so this special structure can help us improve the efficiency. If small, relatively small, then not worth it, right? Yeah, because to build the tree structure, you need to pay a lot of overhead, a lot of cost and overhead, right? Yeah. There is a cost. Every time when you do something new, there is a cost associated with it. Yeah. All right. Yeah. So, if you do not have large number of rows, records, then not worth it. Okay, not worth the building cost. Yeah. All right. So it's we call it multi-level indexes. All right. And another thing is, after, so think about another important understanding you also need to have is, after we build multi-level indexes, so we need to build it first. After you build it, then, because our data has this property, dynamic structure. Because our business data in the real world applications, our business data, keeps changing, right? Keeps changing. Yeah. So the records modified, the records, deleted, the new records inserted. So it's a dynamic process. Yeah. So that means you need to maintain your tree structure in a dynamic way. Dynamic way. Okay? Yeah. So, lot of sophisticated algorithms you need to do behind the scene in order to support dynamic tree structure. You need to do a lot of special operations algorithmically, okay, behind the scene. Yeah. So very complicated, sophisticated in DBMS. A lot of things, but hidden, the users cannot see. All those things happen behind the scene. Okay, all right. Then hashing, so that's for the binary search based indexing technique. Then another one, small portion, the cases for this hashing one, when there is no total order, the small, that one we can still apply indexing technique, but this time we need to use the hashing technique. All right. The hashing, fast but no order information. So for the hashing case, so let me say something about the hashing case. Let me see how much time I left. All right, but otherwise, if I do not explain a little more hashing, so you may have a lot of questions. You may not feel comfortable when I talk about the hashing technique. All right, so the hashing. So here we still, the underlying storage structure for this hashing technique still an array, okay? Underlying, we still imagine our data in an array. But this array, not ordered. Not ordered, okay? Because the hashing technique does not rely on order information. Hashing technique does not rely on order information. Okay, so the order is not important. When we apply hashing technique, Order is not important. Okay, the hashing technique, it relies on matching, data matching. Okay, data matching. Okay, so what's the data matching? You compare if two pieces of data equal or not. Okay, DAT1, you only compare for matching. Okay, you do not compare for ordering. You compare two pieces of data for matching. DAT1, DAT2 equal or not. Okay, when you do comparison, you only compare they are equal or not. Equal or not. You do not compare which one is larger, which one is smaller. Okay? Yeah. Yeah. So that's the only operation we need for hashing. Okay? Matching or not matching. Only two cases. Alright. So then, in order to organize the data in a special structure, the special structure we call a hash table. A special table, we call a hash table. Okay? Hash table. And we need to hash the data from the original storage array to this hash table. Okay? We need to hash, so, operation, hash operation. So what's a hash operation? Mapping. Okay? So what's the hash operation? So here, let me describe this hash operation. Hash operation means map. Mapping, map. A data item by a special function we call the hash function. Okay? Yeah. So that's the basic arrangement for hashing technique. Okay? So recall for those students, if you forget the details about hashing technique, just give you some main points, main properties in this technique. So later, I will explain more about this hashing technique. Yeah. All right. So let me summarize this hashing technique a little bit. Yeah. So you store, so your data, you have the original data source. Okay. So we treat an unordered array as original data source. Yeah. But if we want to do the search on the original data source, too slow. Now we want to speed up the search operation on the original data source to make it faster. How fast? Here I can also give you the result of this hashing technique if we use the asymptotic notation, big theta of n. That big theta of n, that's the building cost of the hashing. Okay, this is the building cost, because building hash table, you need to spend some cost. So this is the building cost. Building cost. And the search cost, after you build a hash table, then you enjoy the fast search operation. That's the big theta of 1. Very fast, constant. Big 1 means constant. Big theta of 1. And this is the average case efficiency. Okay? Not the worst case. Okay? Not the worst case. It's the average case efficiency. AVG. Average case efficiency. Big theta of 1. That's how fast this hashing technique can do. So that's the, basic information about the hashing. All right, so how indexing works. So let's look at more detail. How indexing works. Find a record in a table. That's the search operation, right? Yeah. Because the reason we use this technique or technology in order to, so the targeting operation, the search operation. Yeah. So find a record in a table fast. How to find? How to find? All right. A search condition based on a field. Where clause, right? Yeah. So here, search condition in the where clause. In the where clause, you specify the search condition. Okay, all right. And the search condition based on one particular field. So there is a field. Okay. You need to apply your search operation. Then, in order to make the search operation faster, you need to build an index file on this field. Yeah. All right, so assume an index file is created. Yeah. You need to create it. Okay. Yeah. If you do not do it explicitly, the DBMS does not do it for you automatically. Okay. Yeah. Because think about it, you need to use extra amount of space. You need to use more space. So by default, DBMS does not do it for you. Okay? So the DBMS does not do it by default. Okay? Yeah. All right. Yeah. But you need to write a SQL statement. Yeah. How to do it? You write a SQL statement. Create index. Just like you create a table, right? Create index there. You provide some necessary information after that. Okay? So you ask the DBMS to create an index file for you. Okay? All right. Then, after that, when you apply a search operation on the original data, this time you apply the search operation on the index file first. Okay? The index file, because the data is ordered. So here, I use example because data order, that's the the largest part situation, the dominant case. The dominant case, it's ordered. Okay, yeah. So here I use the example, but we can use that to help us understand. Okay, so here we imagine ordered data. Okay, in this index file, ordered data in the index file. The index is a file. Okay, or table. Okay, yeah. File table. Yeah. Same thing here. So you search the ordered index file, so you can apply binary search. So very fast. Okay. In the original table, you cannot apply binary search, right? original data, the data is not organized based on any particular order. No order, no specific order is used. Okay, yeah. But in your index file, yeah, the DBMS, yeah. So you do not need to do anything. You just tell your DBMS. The DBMS will sort it automatically for you. Okay, yeah. You only need to tell, I want the index file on one particular field. So then the DBMS does the remaining work for you. Okay? Yeah, that's good enough. Yeah. All right. The search result of the index, yeah, your binary search, it will return search result, right? Yeah. What's the format of the search result? Yeah. Later we will get more and more detailed information. Yeah. On this slide, we do not see the specific form of the search result. Yeah. Just you have the search result telling you the location of the record that contains the search key. Okay, that matches the search condition, the search result. Okay, yeah. All right. So the search result is a pointer. Pointer, we know, point to the location, right? Point to the disk block. So what's the disk block, right? So here, so you can see a lot of details you need to know to understand. Yeah. Pointer to a disk block that contains the original requested record. Yeah. So this sentence contains a lot of information, or it requires a lot of background information. It requires a lot of background information to understand the sentence. Okay, a pointer to, we know the pointer point to location, right? Yeah, point to the location. Address, okay, location. Yeah. So that is the address. Okay, yeah. Address, because this block, so in address, not in memory, right? In the hard drive. Address in the hard drive, not in main memory. Okay? Main memory, that address is not permanent, right? Address in main memory is temporary. But the location, address in the hard drive, that's permanent. Permanent address, hard drive. So if after you shut down the computer, it's still there. Okay. Next time you start computer, then you can use the same address location. All right. So pointer to the disk block. So what's the disk block? I need to explain this concept. What's the disk block? That contains the original requested record. Right? Yeah. So this sentence, we need a lot of background knowledge to understand. Okay? A lot. Let me see how much time I have. Yeah. Today, yeah, because I only have a few minutes. Today I cannot expand this part, because this part I need to draw a diagram. Draw a diagram in the hard drive to show you what's the concept of disk block. So that information is very important. But let me see, yeah, but I don't want to start a new topic at this time, okay? All right, so here, let me use these a few minutes to talk about this disk block concept. All right, so we start with hard drive. The structure in the hard drive, okay? Yeah. How do we store data in a hard drive? In a hard drive, so typically the hard drive disk, hard disk, there are the format of the hard drive disk. So it's a cylinder, right? So let me draw a cylinder. Okay. So your hard drive may contain multiple cylinders. Here we only talk about one cylinder. Okay? One of the cylinders in your hard drive. Okay? One of the cylinders. In this cylinder, there are many disks, slice, okay? Because the cylinder is organized. Many disks. So, disk. Okay? One disk. Disk 1, 2, 3, 4. Okay? 1, 2, 3. Yeah. A sequence of disks piled to form one cylinder. Okay? Yeah. All right. Then let's talk about one disk. So let me draw one disk in this view. One typical disk. One disk. Okay, all right. One disk has two faces, right? Two surfaces, two sides. You can store data on two sides. Okay? Yeah. Two sides. Store data two sides. Okay. All right. Now we just look at one side. Okay. So for the one side, then we split the one side of the disk into many tracks. Yeah. So all these concentric circles, what we call tracks. These tracks. Okay. Yeah. Because to store data on this disk space, so we need to organize the disk in all these concentric tracks. Okay, all right. Then the concentric tracks, but still, for each track, how do you organize the data for each track? Okay, so we need to further split data on each track in sectors. All right. So we cut the data, okay, for each track. So we cut into these sectors. Okay. Each sector, a portion of the track. Okay? A portion of the track, one sector. Okay. Then, for the sector, still, that amount of space still relatively large. So for the sector, we need to further split the sector into disk blocks. Then we get to the disk block concept. Okay. All right. So here, let me enlarge one sector. So suppose this is a portion, one sector in a track. Okay. Still, this part is relatively large. We need to further split into smaller units. Then that smaller units, several smaller units, that's correspond to one disk block. Sorry. That's the concept, disk block concept. Okay, all right. Then, when we store the data, we use this data storage unit. This is our basic storage unit. Basic data storage unit on hard disk. Block by block. Okay, this store your data. Block by block. All right, yeah, let me look at the time. Yeah. All right, already 8:08. Yeah, let me stop right here. Okay, so next time, let me, continue this story. Yeah, so I will use this background knowledge to explain the indexing technique. Okay, yeah. All right, so that's it. Yeah.